Greetings to everyone here today joining our Innovation Speaker Series. The Atlantic Canada Climate Network is proud to co-present this event with the Canadian Environmental Network. We have come together for this project to showcase cutting-edge emergent technologies and their potential to advance climate solutions and create new opportunities. Before I begin, I would love to respectfully recognize and acknowledge the relationship with the First Nations, Inuit, and Métis across Canada that they have with the land all Canadians live on and enjoy. We would like to recognize that the ACCN here, the Atlantic Canada Climate Network, operates on the traditional unceded territory of the Mi'kmaq, Wolastoqiyik, Passamaquoddy, Penobscot, and Abenaki nations, or the Wabanaki Confederacy, as well as Innu and Inuit peoples. This territory is covered by treaties of peace and friendship, which these nations first signed with the British Crown in 1726. These treaties did not deal with the surrender of lands and resources, but in fact established the rules for what was to be an ongoing relationship between nations. So it is in this spirit of peace and friendship that I greet you all today. It also reminds us of each of the 634 different nation communities, 53 Inuit communities, and 8 Métis settlements that have a unique historical, cultural, spiritual, and environmentally sustainable connection to the land that their people and ancestors have inhabited since time immemorial. We encourage all Canadians and visitors to these lands to learn about and regularly acknowledge the historic and current relationship that exists between the unceded lands on which we live and work and the First Nation, Inuit, and Métis peoples. We also acknowledge all and encourage all Canadians to consider how they can personally contribute to Canada's reconciliation with Indigenous peoples. Now, the Innovation Speaker Series aims to foster collaboration and knowledge exchange amongst diverse stakeholders passionate about addressing climate change. Today, we have the privilege of immersing ourselves in the remarkable journey into the future of sustainable development in municipalities with Dr. Kuljeet Singh Grewal. Now, Dr. Kuljeet Singh Grewal is currently actually working as an assistant professor at the Faculty of Sustainable Design Engineering and is cross-appointed with the School of Climate Change and Adaptation at the University of Prince Edward Island, that's UPEI. Currently, his transdisciplinary research focuses on sustainable neighborhoods and energy design that also involves the planning of clean energy resources. Upon joining UPEI in September of 2021, he established the Future Urban and Energy Lab for Sustainability called Fuel S. The area of work involves energy efficient urban design and energy resources, including their planning and optimization, promoting long-term sustainability, technological, economic, and environmental adaptation. So Dr. Grewal is contributing to is actually a subtask leader for Task 63. That's the Solar Neighborhood Planning of International Energy Agency. That's the IEA. And he's currently leading a number of funded projects through NSERC, MITAX, industry partners, and governments, devising novel energy modeling and planning techniques, showcasing innovation leadership, as well as fostering community-led transitions in a living lab. So to date, Dr. Grewal has published 33 top-notch, peer-reviewed international journal articles, 14 international conference contributions, 2 international reports for IEA, and a book chapter. So without further ado, I am very pleased to introduce our wonderful and esteemed guest. Over to you, Kuljeet.
Thank you, Ashley, for this wonderful introduction. Thank you for this invitation, and I'm glad to present here today. Okay, so let's get started. Today, this is the presentation topic that I will be covering, the role of built environment in net zero goals and its transformation. And I do want to acknowledge first that we work, live, learn, and grow in the unceded territory of Mi'kmaq people here in PEI. Okay, so let's dive into it. So what you can hope from today's talk, we will be covering these topics, or this is the agenda for today's presentation. First, I will be introducing my lab, that is Fuel S, Future Urban Energy Lab for Sustainability. And then I will be talking about urban ecosystem and sustainable energy, tools and automation that we are doing, mixture of buildings and energy, how does that impact? the energy performance of neighborhoods and urban areas. Then I will talk about solar access and resilience, IEA Task 63 activities that my research lab is having in collaboration with other experts. Um, then I will talk about hybrid sustainable energy infrastructure initiatives that we are having in PEI. And then I will talk about Georgetown PEI Living Lab that we are establishing or fostering in collaboration with the PEI Energy Corporation or the Prince Edward Island government. So this is about the making of my research group. So I joined UPEI in September 2021. Then upon joining, I established my research lab called FUEL-S, Future Urban and Energy Lab for Sustainability. So it's a really transdisciplinary kind of research environment. And it's a mix of urban planning and architecture and a couple of engineering disciplines, and then economics and policy making. And this research is really bringing everyone together to foster high performance building design, future urban designs, clean transportation, and sustainable energy design. So this is the theme of my research group here. And so these are some of the opportunities and outcomes that we are proud to share, that our research aligns well with all these things. So it aligns well with the Atlantic Provinces goals, Pan-Canadian Sustainability Framework, UN Sustainability Goals, particularly SDG, Sustainable Development Goal 7, 11, 12, 13, and 14. And then we are intending to have Sustainable Local Energy Economy Framework. Automation is one of our key things in the research. Design strategies for new and existing sustainable new neighborhoods to attain net zero future, and policies, how we can shape policies, and those policies has to be data driven. So that's we are basically focusing pretty much. And then useful to establish neighborhood level energy codes. So right now in Canada, there are only building level energy codes. There is no standard neighborhood level energy code. So this research also feeds into this idea, like attaining not only a building as net zero, but to attain whole building cluster as net zero, basically. So these are some of the things, and this is vision of my research lab: real life adoption of sustainable energy infrastructure, promoting clean energy storage, economic and environmental goals, attaining energy security and affordability. And these are some of the things we are doing. We are dealing with energy efficient mixed use buildings. Like mixed use, from mixed use, what I mean is whether it is residential, commercial, institutional, what sort of building is it? And then energy oriented urban planning, how we can do urban planning from the energy perspective, and then how we can mix different energy resources together. And then mixing of synergy between existing and new neighborhoods. And then so the space of energy is so dynamic, like everything every day, like new innovations are coming up and field is so dynamic. So we are also adopting all those new energy resources as well. And then weather uncertainties, we are quantifying that as well. Techno-economic, social uncertainties, local energy economy, and co-creation. We are insisting on co-creation as well, because the net zero transition is not only attained by research only. Ultimately, we have to engage community in the journey from an early stage, basically, and I will be talking about it. And that ultimately that foster a living lab kind of culture that we are developing here in PEI. And then AI is a big part of our research, artificial intelligence. So we are integrating it for energy modeling and planning. And then GIS-based techno-economic energy planning tools. We are working on a couple of tools as well. And then we are also one project we did on clean transportation as well. Water management is also going forward, like overarching goal. And one project is running on sustainable agriculture. So this is also this is the overview of the group activities that is what we are doing. So specifically, one of the major focus is on urban scale sustainable energy design. So I'm going to talk talk first, like what does this mean actually? So when we consider any building, let's say whether it is residential, commercial, institutional, or industrial, whatever the building is, these are some of the key aspects when it comes to energy demand profile. So it's energy demand of energy demand of any building will depend on shape of the building, layout of the building, the energy system you are using, whether you are using heat pumps, oil furnace, what sort of energy system you are using, whether the building is new or existing, because it will govern what is the building envelope, like what is the wall insulation value, what is the roof insulation value, and then the type of use. For sure, the energy profile will be different for a residential building, different for commercial building, like the profile of energy consumption, I mean. And then the facade design, facade is the envelope or the outdoor surface of our building. What type of facade design is there? What type of windows are using? What type of doors we are using? So at building scale, these parameters will affect. For example, if you want to attain net zero energy building, then primarily you will be considering all these aspects, and then you will plan your sustainable energy resources or sustainable energy decision making accordingly. But when it comes to a neighborhood scale or an urban scale, when you are considering not one building, but a cluster of buildings or mix of buildings with the land use. So when you are now you have broadened the space. Now you are considering mix of land use, maybe different type of buildings, different type of land uses. And then if the neighborhood itself is new or existing, or it will be it may be mix of existing and new buildings as well. What is the density of buildings? Like how whether our neighborhoods are scattered or they are more densely populated. For example, downtown would be a perfect example for densely populated neighborhood, and maybe some suburb areas are more scattered or low density neighborhoods. So that will also impact energy demand profiles. And then what is the layout of the neighborhood? For example, if most of the buildings are south oriented, or if they are having big windows on south, then for sure those buildings will be heated with solar energy. So in that way, that energy demand can be reduced. So now if you consider a street layout and how buildings are organized or how buildings are situated with respect to that street layout, whether it is north, south, east, west, or what sort of orientation is there. So that will also impact your energy performance. So in a nutshell, when the urban scale is there, there is a lot of variability, lot more variables, but there is one advantage. So when you are considering building level energy planning or sustainable energy decision making, then you are looking at limited energy resources. Maybe you can only install PV on your rooftops or solar thermal on your rooftops. Maybe you can have a local energy storage and then you can integrate it with grid. But when it comes to neighborhood scale or bigger scale, or when you are considering cluster of buildings, then you can even diversify these energy sources further. For example, you can consider wind energy as well, that you can not feasibly implement on building scale, but when you are considering cluster of buildings, then you can consider that option as well. Maybe district heating is one of the options. Maybe you are using biogas or bioenergy, bio waste to generate energy on the neighborhood scale when number of clusters, number of buildings are involved. Then you can also look at large scale and energy storage solutions, such as borehole thermal energy storage, where you are just using ground to dump heat to store energy. So that is also kind of option. So in a nutshell, the point is that whenever you are going from building scale to urban scale or bigger scale, then you have a lot of choices of energy resources, and also you have liberal economics. What I mean by liberal economics, this is recent report or report published in 2020 by NREL, National Renewable Energy Lab in US. And they compared the cost of various solar energy solutions. So for example, if you are only considering it for residential building, let's say if you are owning a building and you consider putting solar on your rooftop or in your building, then this is the cost that you are looking at. And if if you if you come to utility scale or bigger scale, when you are considering a building stock or multiple buildings, then your economics is much more liberal. It is almost less than half of the cost that you are incurring on a residential scale. So that's how, if you are enlarging your scale, then you are ultimately resulting in less cost for your energy installation. So that that will make the economics more liberal in implementing clean energy solutions. So these are few sustainable urban design objectives. For example, first objective is energy efficiency of buildings and their system. This is the primary thing. Often whenever we are hearing about net zero, we always think about solar energy or wind energy or bioenergy, whatever you are thinking. But it's not about only generation side of things. We can generate energy for sure. It should be clean. But at the same time, we have to ensure that our buildings or built environment is efficient enough so that we are not pouring heat to a house that is leaking heat or having a poor insulation value. So all the heat that we are dumping in, that is being lost. So the primary thing is to make our buildings efficient first. So for how we can do that, we can use high performance building envelope. Maybe we can use better insulation value. We can incorporate passive design. Passive design is similar to what I was talking before. Just we can have south facing window in our house, and then you can just heat your house with that solar energy. For instance, in my house, my living area has a big window that is facing south, and in the afternoon we never turn on heat pump on a sunny day, because it's more than enough to heat our space during when the sun is shining. So in that way, we can cut down the cost. It is not only about active generation, and we can have efficient mechanical system like heat pumps. So these are pretty popular in Atlantic Canada because, like if we consider specifically PEI, there was strong reliance on furnace oil. Now people are switching to heat pumps. That is more efficient way of heating our buildings. And then the optimal urban design, we may also mix different buildings together strategically so that the energy demand can be managed pretty efficiently, or utilize the clean energy can be efficiently utilized. For instance, like commercial buildings will be having a different energy demand profile. For instance, if a business is opening 9 a.m. in the morning, so they will be consuming energy till 5 p.m., let's say. But in opposed to that, if a residential unit is there, if people are working, then they are going out at 9 a.m. and then they are coming back around 5 or 6. So their energy demand will be less during the day for residential building, but for commercial building, the demand will be higher during the day. So in that way, if we mix strategically buildings together, they can complement each other. They can the building energy profiles can complement each other, especially when we are trying to rely on renewable energy, because renewable energy itself is unpredictable. And for for example, if you are having solar energy, then you can rely on solar energy during the day, and during the night, maybe you need to look at some alternative. So maximum onset energy generation. So optimal building design is there. So if we are having our optimal building design or maximum south facing area or maximum south facing roof area, then we can also have more solar panels that can be installed onto the rooftop. So that can be also strategically planned. Optimal neighborhood arrangement, so that there is no issue of self-shading. This is the problem specifically in downtown neighborhoods when high-rise buildings are there, and if high-rise building is covering some low-rise building, so maybe they will be restricting the solar access to those buildings that can affect the energy performance of building. So that will come as solar access or solar rights thing as well. But we can also optimally plan our neighborhood. And then hybrid and clean energy. So I always say to my student, like, future is not only about solar, it is not only about wind, but it is about hybrid infrastructure, how we can mix different energy resources together. Maybe wind can solar complement each other. When we are not having wind energy, maybe solar can complement. When we are not having solar energy, maybe wind can complement. And accordingly, like hydrogen can complement, bioenergy can complement. So this is how, if we strategically plan our hybrid clean energy, then it would be good for our net zero future. And then resilient communities, energy resilience and infrastructure resilience. This is pretty important for Atlantic Canada, especially when we are experiencing a lot of extreme events. Like we had Fiona last year, and then it was devastating, like all that power outage that happened. So like for days in some areas in PEI, we lost power for around 3 weeks. And it is pretty substantial to manage our day-to-day life activities. So energy resilience and infrastructure resilience is also one of the key aspect. And then low emission transportation. EVs are there, but EVs are not the sole solution for transportation. There should be alternative methods, like Toyota is working on hydrogen engine, ammonia is being seen as fuel, or also ethanol and all those alternatives. So it is not only about EVs, but diversifying in that space as well. So the ultimate goal is sustainable urban infrastructure. So whatever feeds into the sustainable urban infrastructure has to be tackled to achieve net zero. So specifically for building stock, or if we are considering buildings, so when we are considering buildings, there are several variables that can influence energy of your home, let's say, or of any building. For example, building envelope performance. Envelope is all those outer envelopes that you are having on your house. For example, your outer walls or your roof. So all those are building envelopes. Your windows and doors, all those are building envelopes. And how insulated your walls are, it will affect your building performance. If you are having double glazed windows, triple glazed windows, or single glazed windows, it will impact your energy performance. And then detailed geometry in location and orientation. So as I was talking, whether like what is the orientation of building, what is the floor area, if you are having 2 floors, 3 floors, or single floor. So all those things will matter. And then operational profiles, how you are occupying the building. As I was comparing commercial buildings and residential buildings. So what are the operational profiles, how you are consuming energy and how you are generating energy, and what are the HVAC system, heating, ventilation, and air conditioning system you are using, what sort of ventilation you are using, internal gains, like what sort of appliances you have, let's say. So for example, if a computer is running right now in my office, it's an internal gain. So I'm gaining heat from my processor or from my CPU. So all those things has to be modeled if we want to predict the energy consumption or energy consumption profile of a building. So there are a couple of software packages that are out there. Most popular is Energy Plus. Energy Plus is developed by NREL, National Renewable Energy Lab. And it is pretty comprehensive. You can define each and every parameter that I talked about, and you can just simulate your building. So for example, you can have the geometry of your building, and then you can define all these parameters related to buildings. And then from there, you can estimate like how are the And then you can source the local weather file, and then based on that you can just estimate how your building will be performing, like what is the energy demand profile, like how the heat is flowing and stuff like that. And then there are other software packages like OpenStudio. It is also from NREL, and Rhinoceros Grasshopper. It is also very good tool that is recently popular in this space. And there are for sure more tools that are there, but these are some of key tools that are there in the space of building energy modeling. So why building energy modeling? Building energy modeling has multiple benefits. So it can be used for policy analysis, for financial incentives, retrofitting. Right now, I will be talking about it more, but you can, from energy modeling, you can easily see like what sort of retrofitting your building will be needing, predictive control, maintenance as one of the perspective, code compliance. So now any CB, National Energy Code for buildings is out there. So you can check the code, whether your building is complying with that code. Asset rating is there, architectural design. So these are multiple benefit, and LEED is also one of the benefits. LEED is kind of a certification, leadership in energy and environmental design. So it can also, like most of commercial buildings are interested to have this certification, so it can increase the asset value, and they are considering a couple of sustainability parameters. So energy modeling can feed into that LEED certification thing as well. Now I talked about building energy modeling. So when we are having one building and we are setting up all those parameters like envelope or energy system, all those parameters that I talked about. Now when we are increasing the scale, let's say to neighborhood. So let's say if this is a neighborhood where you are having single detached houses, primary school, small restaurant, standalone retail, supermarket. So this is a mixed use neighborhood we typically call in architecture or urban planning. So when you are having different building use or different land use, basically. So in this case, there are few challenges. Now you have increased your scale from a building to neighborhood. Now it is more complex to set up, more time consuming task. Now you are taking too many parameters into account. Maybe one building would be different than other. Like for example, what is the insulation value of one building? It will not be same as your neighbor, right? So there will be a lot of variability in the building stock that you have to take. A lot of schedules. Maybe some people are going to night shift, some people are going to day shift. So that sort of thing. Whenever we are considering residential buildings, energy systems. So there will be diversity of energy systems. Some are using maybe wood-fired heating system. Some are using furnace oil. Some are using heat pumps. Some are using electrical water heating. Some are using oil water heating, propane water heating. So there is so much of a diversity in energy systems as well. And the internal loads, of course, internal loads will be also different. Then, for example, if you are having same or similar building, then you have to remodel all those buildings. So it is a very time-consuming task in a nutshell. So that's why in FuelS we are incorporating a lot of, or we are leveraging with a lot of machine learning and artificial intelligence stuff. And I want to automate this process down the line so that like the modeling can be done at faster pace for net zero transitions. So this is one of the examples that we have recently done, and it got published in a reputed journal of energy and buildings in our field, and where we were developed several archetypes of buildings. And so we coupled different tools like SketchUp, Energy Plus, MATLAB, Python together to automatically create 3D model of buildings or to set up 3D energy models. So first in this method, first we are individually setting up building energy models, and then we are feeding to this algorithm. So this will take all those energy model files and it will merge all those files together to create neighborhood energy model. So it is, although I'm talking it in a simpler term, like merging is not easy because it is itself very complex task because of variety of variables. So anyway, to tackle this problem, we have made this algorithm, and that works pretty well. And then this is the mixture of energy mixture of buildings that I was talking about. So for example, here in this study, we have studied how the mixture of residential buildings will impact the energy performance. So in Canada, primarily, we are having three type of buildings like single detached, townhouses, or semi-detached houses. Um, like all the townhouses are a little different, but in this study, we have considered this in the same space. And the apartment buildings. So these three are main type of buildings that we are having. And then what is the commercial to residential floor area ratio? So in this particular study, we have considered mixed use neighborhood where we are partly the neighborhood is developed as residential and partly it is developed as commercial. And then what is the unit density index? Like how many units are there in per acre of land or per hectare of land. And then these are the performance parameters that we have considered. We have considered net electricity consumption ratio of performance, like what we are generating and what we are consuming. And then we have assumed PV generation as well in the study on the buildings and waste to energy. We also considered this waste to energy generation. And then what is the GHG emission that is coming out of this mixture. So maybe this triangle looks a little complicated to you, but it is representing the mix of energy, mix of building units basically. So in stat, it called crossed mixture statistical design. So this is the method that a lot of pharmaceutical companies using or chemical engineering companies using to see like how mixing different chemical impacted desired output that they are needing. So I utilize the same concept to simulate buildings basically. For example, here, if we are having some 100% single detached houses, here if we are having 100% apartments, 100% townhouses, and in between there will be mixture of all these type of houses, residential buildings. For example, at the center, there will be equal mix of each building, basically 33% single detached townhouses and apartment buildings. And then we have set up a couple of objective functions with respect to these design variables. And then we fed it to a multi-objective optimization engine so that we can see like how the mixture will look like. So these are some of the results that we got. For example, in this case, you can see like how the mixture of different buildings together will impact the energy performance. And this is net electrical consumption, since apartment buildings will be having multiple units. So these are more energy intensive units out there. And then whenever we are moving around within this triangle, then we can see like how the energy consumption will be varying. And similarly, we have done this with commercial buildings. If we are mixing together commercial buildings, how does that impact the energy performance? And then finally, how we can mix different buildings together, like for example, to achieve net zero or to optimize all these design parameters, how we can mix different buildings together. And so in that way, we can see like how well we can attain net zero energy in the future neighborhoods. So this is also one of the ideas that we are having, so that buildings can be mixed together to attain net zero. This is also one of the pieces of my research, which is towards solar neighborhood planning. This is task 63 of International Energy Agency task 63, where we are having different subtasks. So I'm leading subtask, co-leading subtask A, basically in this task of IA. And what we are doing for Canadian neighborhoods, we have developed a couple of real life archetypes, archetype energy models. For example, these are two neighborhoods that we are selected. And then we have energy model these neighborhoods, and then we have analyzed it from the solar perspective, like how much active solar we can generate, how much passive, what is the passive performance, and based on that, how we can install solar collectors or how we can do solar installations within the neighborhood. And then we also tried retrofitting on these buildings. Like, for example, if we are retrofitting these buildings with more insulation and stuff like that, how much? So this is the baseline 100%. Then how much we can reduce with retrofitting with energy efficiency, and how much we can reduce with retrofitting and solar energy generation, basically. Then as part of task, we also developed a couple of neighborhood archetypes within the Canada. For example, here I'm showing residential archetypes, mixed use archetypes, high density archetypes, just like downtown areas. And then we have also used genetic algorithm to optimize mix of energy resources. Like here we have optimized wind, PV, waste to energy, and grid together, like conventional resources and distributed energy together, to attain net zero energy, basically. And then this is another elaboration on the IA task activities, but this is not part of IA task, but we have elaborated this research further, where this is the mixed use neighborhood that we have set up, and then we have quantified its electrical vulnerability. Like, we want to assess the energy resilience of these communities. For example, if some power outage has happened during some extreme event, how energy vulnerable those net zero neighborhoods are. Like how much we can generate, how much solar energy we can generate, how those neighborhoods can survive, basically. So this is also a perspective, and we have set up a vulnerability index, and based on that index, we have quantified different neighborhoods in different seasons and how they are vulnerable. And then we can just take this vulnerability index and try to optimize the design of our hybrid energy infrastructure to minimize this vulnerability. That is also one of the pieces that we have done. So coming to PEI, so in PEI also we are having a number of initiatives. One of the initiatives is the project that I'm going to talk or touch briefly today. But overall, province wants to attain net zero by 2040, and there are a couple of initiatives, like a couple of funds are there, and a lot of exciting things are going in the province. So government also identified one of the desire to work with academia to better understand energy consumption and emission of the communities. So this research is part of the community energy planning of Prince Edward Island. And so they reached out to us, and then we planned this project on Georgetown, PEI. It's a small town here in PEI. It is having around 300 buildings, so it is a scaled size. And then this project got kicked off. It's on assessing the potential of PEI's first net zero community. That would be potentially Georgetown. And this project kicked off on October 5th. And then this is the overview of the project. So this is map of Georgetown. So it has a perimeter of 5.6 kilometer and area of 1.6 kilometer square, and this is the objective to assess net zero potential of Georgetown. Then our approach is comprehensive energy modeling and planning approach. Then these are the phases of the project. First, we are energy modeling existing Georgetown. Then we are evaluating the impact of building envelope improvement and electrification, how retrofitting will improve the energy efficiency of the neighborhood or of Georgetown. And then we will be planning hybrid energy mix for Georgetown. Then the phase 4 is on resilience study and assessment of the impact of climate change on the implemented scenarios. For example, going forward, if climate change will keep on happening, then maybe what we are designing today, that may be not sufficient for tomorrow, like down the line, 10 years, 15 years, right? So we want to study that as well, like if climate change is there, how our energy systems will be impacted. So this is the phase 1. First, we are getting all that historic weather data, building use data, occupancy data, building envelope data, energy system data, GIS data. We are all integrating all these data sources to set up a prelim neighborhood energy model. Then we will calibrate this model with utility data with the help of machine learning. Then we want to have a kind of digital twin, you can say, of Georgetown with what is out there as a baseline case. And then we will be assessing retrofitting strategies, like, for example, now first we know what is existing Georgetown. If we are retrofitting buildings, then how much energy we can save, or how efficient buildings can be. And then if we do electrification, then what is the impact of electrification as well. So I'm very proud to announce this, like we are on path of fostering Georgetown as a living lab. So it's a living lab. Why it is a living lab? Because it's a real life context for sure. And we are collaborating with community, with government actors, with private partners, and we itself, an academic institution. And we are fostering Georgetown as a living lab. We are having a lot of community engagement. So till date, we had 3 sessions in last 3 months. So we have a couple of volunteers in the community as well. And then we are collecting data, real life data. And of course, scientific research is one of the pieces in the project as well. So that's why we are now co-creating a net zero community in Prince Edward Island, and it's a living lab. So we are involving people in data collection as well. So I will be touching that up as well. So this is the research progress till date on this particular project. So we are playing with LiDAR data from the province. So LiDAR data is a laser data that is collected from an aircraft. So it is a very scary kind of data set if you look at, but you will be having a lot of points of all the surfaces on ground. So we are processing all that LiDAR data, and now we are able to attain LOD2 model, level of detail 2 model. So this is the model that we have developed from LiDAR data. So from this black and white images, we are able to develop this sort of LOD2 model for one block in Georgetown. And then now we have automated the process. So just we can easily replicate or rapidly replicate all that process. Now, the problem with the LiDAR data, we are only able to generate building models without windows and doors. So to tackle that problem, we are flying our own drones in the community as well. So from that, we are processing that data with machine learning. So we are labeling that data, and then we are deploying supervised machine learning to detect windows and doors. Then that data will be superimposed to LiDAR data model that we have developed, that you have seen in the previous slide. So from that, like, we are envisioning to automate this process so that you are only inputting LiDAR data and a couple of images of the neighborhood. Then it would automatically generate 3D modeling models or 3D neighborhood models for you. So right now, people are doing this process very manually, but we are heavily automating it. And this is not only relevant for PEI, but for whole world. So my one of my colleagues from Norway, like who are also working on IA task, so he want to use this technology to develop 3D building models, because right now the process is pretty much manual. So we are also having building envelope data from NRCan, Natural Resource Canada, but and recently we started browsing this data. So we because NRCan also doing energy audits through their EnerGuide program. So, but this data from this data, like we discovered that there is a lot of variability in envelope characteristics. Like, for example, this is your wall insulation value, and see you can see like from the year of construction, you can't really assume like an insulation value, because there was no building code followed in PEI before 2020. So due to this variability, we can't just first identify the year of construction and then assume the insulation value. So that's why we plan to diversify this building envelope characterization process. So for that, we are using energy audits from NRCan. And another problem with energy audit, we don't have address identities in that data. So we don't know like which building. So in that energy audit, you will see insulation values and what is the energy system out there, but you can't see the address because of privacy perspective. They are not sharing that data with us, so we don't. So that data is anonymous. And then we are doing expert consultations. We are using national energy code for buildings. Then we recently we launched this community-led data collection. So then we thought like, why can't community collect their own data and then report back to us? So we recently launched this initiative. And then we are doing building imaging as well, overhead imaging and outdoor imaging, thermal imaging. So this is the community-led data collection. So we have set up a few kits with the infrared cameras, hygrometer, measuring tape, and then data collection sheets. And then people can just take these kits and measure take some thermal imaging of their outdoors and indoors, basically. And then they are reporting back to us, and then we can collect that data, process that data to estimate the insulation values. And this is the data that we are collecting: year of construction, last renovation, what is their occupancy and schedule, outdoor wall thickness, window types, indoor and outdoor thermal imaging, building envelope information, addresses, energy system, and consumption. So it is a pretty comprehensive study that we are running. And this is these are the pictures from community training session. So we had a training session in community where we have trained people. And recently this got captured by CBC, and one of the community members said like it is eye-opening for them to see like how the heat is being lost from their home. So this sort of event, this sort of initiative is not only feeding us data, but it is also creating awareness in the community, like how they are using energy and how the energy is leaking. So we are also having a couple of community champions who are helping us in this community-led data collection process. Until date, we have covered, yesterday's number was around 140. So we have covered 140 buildings with this community-led data collection. So in the nutshell, what is the bottom line? Going forward, we have to improve our energy efficiency of buildings. So first, we have to conserve our energy. Then we have to diversify our energy resources. It is not only solar, not only wind, but as much as the diversification that we can have. Energy storage is one of the important aspect of net zero future, because uh, all those renewable energy resources are non-programmable. Like you can't really control wind, you can't really control solar, right? So to ensure energy resilience of communities, you should be having energy storage as well. So these are some of the acknowledgements for Georgetown Living Lab, since we are having so many partners out there in the community, and we are working with the community, government, and private actors. So all these are the acknowledgements for all different collaborators on this research, and these are some of the other acknowledgement for funding: NSERC, MITEX, NRC, and several industrial partners. My research collaborator from Concordia, Dr. Caroline Hecham-Bermite, and Ricardo, one of the students in master students at UCalgary, and my team here, my graduate students, undergraduate student, and international interns. Yeah, so this is it. So I'm a little bit over time, but still, I think we have around 10 minutes for Q&A, and I would love to hear any questions from the audience.
Thank you. That was absolutely amazing. I've learned so much. It is question and answer period. So if you have a question, please feel free to drop your question in the chat, or you can unmute yourself now.
I have I'm not sure if it's a question or a comment, but it seems like what we need to do is to think, instead of thinking about individual buildings and builders and all the different actors that are involved in planning the city, business, we need to think in terms of a system.
Yes, absolutely.
We have an energy system at the neighborhood level. And forgive me, but I sort of thought somebody must be doing this already. Like, I mean, it seems so important and so obvious, and yet I'm starting to think that maybe we're not even doing that. We're just thinking about a building and not about how it relates to the buildings around it and the streets and all the other elements.
No, it's pretty important, and one of the things that is certainly I would say a problem, like we are shaping lots of policies around net zero, but there is less awareness from the execution part. So that's where my research feeds in, basically. So you are having a policy and how you want to implement that policy on ground. So that was actually title of my NSERC discovery proposal, like transdisciplinary collaboration, how we can facilitate that through science or through engineering.
Thank you.
Any other questions? I have a question here while people are thinking. You really brought up this machine-led learning a lot, and then there was the idea of these co-created communities. Like, how has the technological innovations driven the ability to perform this type of research?
Yeah, absolutely. Because whenever we are talking about community, there is lots and lots of data. So right now, how we are leveraging technology, first we have bought those high definition infrared cameras, and you can just, it's kind of a fun activity for the community as well. It is not very, very hard. It's similar clicking pictures from your phone, but they are taking that thermal camera and they are clicking those pictures, and then now when it comes to processing that data, so I hate manual things, honestly. So that's where we are implementing this machine learning, because we can just create some algorithm or workflow and then maybe feed all those images together. And those images can be processed, and we can get output whatever we are needing. But it is very complex than I'm talking about, but I want to streamline all this process. So there are physical instruments that we are using from the technology perspective, and now I'm for sure, like in Georgetown, people know what are infrared cameras from general public perspective, and they can know, like, okay, why they are important, how I can see, like, how the heat is moving in my home, right? So from the general public perspective, if anyone doesn't have any engineering background, so it is good for them to know, like, how to use this instrument, and at the same time it's an educational piece for them, right?
Mm-hmm.
Yeah, so we are using that instrumental part thing, and then for data processing, we are relying on machine learning, so that our research is contemporary, not like not like outdated research. So
Yeah, it's very growing and not static. I
yeah,
feel like there is this urge within the work that you're doing to be able to almost package it and scale it across different neighborhoods so
yes,
that it is replicable and that there is a
classical.
system behind this, which I am of course behind. I'm really encouraged by the community-led data collection. I'm wondering, and you kind of touched on this, how it's altered residents' view of efficiency. How has it inspired maybe collective action within the community, or are you seeing any type of advocacy or increased awareness regarding heat loss and environmental issues and efficiency of buildings?
Yeah, absolutely. So now we are getting notes from people. Okay, I can see my house is blowing. So how can I fix that? So these are literally notes we are getting. And the uh, other thing, like my students are so well connected in the community. So Georgetown is a small community, and if you see a car in the community, like everybody calling everyone, like why this blue car is roaming around, and now people are posting pictures on Facebook, or pictures of my students on Facebook. So these folks are doing this sort of work. So if you see them, so just help them. So that post got reshared in the community as well. But the educational piece is going really well as well. So because why we have introduced this educational piece, because I don't want to give a flavor in the community, like maybe after 1 year I will be going in community and see, okay, you need this sort of retrofit, you need this, you need this. Now they know like why I need this. So that sort of sense we are creating from day one with this community engagement. So it is kind of twofold benefit for us. So now they know, okay, that makes sense if they will be proposing some retrofitting strategy or some efficiency improvement stuff. So this is why we are talking about co-creation. We are creating with them, we are modeling with them from day one.
It's brilliant. And I love the idea of coming back with recommendations. Is there any additional resources that you equip citizens with to be able to take on this vital work of energy efficiency independently and like within their own control of their home? Like, are you giving them like outside of just the rundown of how to use the technology and some oversight recommendations, the resources to be able to actually do the work, understanding the installation of heat pumps, understanding uh insulation in general, right? Or like cladding and the exterior of our buildings. Is there any additional education that comes with that as well? Or is that maybe something that is going to happen down the line once the recommendations come out?
Yeah, once the recommendations, or not the recommendations, but this summer we are hoping to build some specimen walls so that people can see, okay, this is what inside there in my wall. And then we will be building couple of samples of the walls, and then people can see, okay, this is how I can maybe put some spray foam insulation or some other sort of insulation. For example, if I want to renovate my house by myself, then I would know like how I can do that, right? So in that way, and that is, I don't want to disclose it fully, but I was also talking to construction association here. So maybe right now we are under crisis of workforce as well, right? So maybe this sort of project or idea can be used for training of individual that can be used as resource in the construction industry. So that sort of training can be also facilitated with this, but I'm a little hesitant because this is still
It's
on
still under
in the
wraps.
initial discussion thing. But that's what I'm envisioning, so that this living lab can train people as well. Like it is training people from the but it can train people from the trade perspective.
Well, that's wonderful. That's absolutely inspiring on a lot of different levels. So thank you for the work that you've done and so much gratitude for you being here. Is there any questions from the audience before we run out of time? Well, wonderful. Thank you again. This has been so insightful. I hope to hear more about this project in the future, and of course about your work. So much gratitude again for you being here, and thank you for sharing some of your knowledge and insights with us.
Many thanks, Ashley, to invite me to this platform, and I'm glad to present here. And looking forward to future presentations as well. And if anyone has any question, so you can also write me at kgrewal@upei.ca. This is my email. Yeah, fantastic. Thank you so very much.